All right, we're recording. Good morning. My name is Brittany Fink. I will be talking to you today about my exam 2 for MENG 4312. Sorry. This is the problem we're going to be talking about today. We will be finding the transfer function as one part of it. We will also talk about our time domain, our curve, our state representation. So to start out with, my assumptions are that the system is at equilibrium. The gear moves clockwise. There's no external work. It has an ideal spring. Can exclude gravity. It has a rounded cylinder for the gear, and the springs are linear. First, I have my free body diagrams. I like to start off with separating the pieces, and what I did was I have the gear at the top and the other half at the bottom corner. Our input is X due to the rotation of the gear being clockwise, and it will help it rotate and show that our output is T. Next thing I like to do is I like to start off with my most basic equations. First we have the K equation, and we got 17.8 Newton meters. Then we have the B equation where we got 4.2. And then we also have on our side for later, we have the J equation that we will need, and we also have the R equation to get our radius. These are our equations. We got these from Newton's second law for the first equation, and then the equation 2 is our torsion motion equation. But then we will combine these two together to get our final equation to start finding our Laplace transformation. I like to put my variables at the top of here just so that way I can quickly look at them as I plug them in. And now I just plugged everything into the equations, and T 25.24 x double dot plus 18.33 x dot plus 1.05 x is what we got here. Now we can take this and go to the Laplace transformation. And then we started with that same equation that I just read out. And then we start to take out our XS down here to show our final transformation function. Right here is our final Laplace. Our state representation function, we start with our equation 3, and then we rework it to move T to the other side. So we went from T here, T to the other side. We then can divide the equation by 25.24. That was from our x double dot. Once we divide each part out, then we get this is our equation, -0.726 x dot minus 0.042 x plus 0.04 t. Next, I have our matrices. So I started with our variables of x1 is x dot and x, and x2 is our x double dot and x. We pulled these equations from our B equation, our K equation, our radius, our mass of the gear, and then we have our 1 over J to help us solve the matrix. We just then plug each of these numbers in, take it times the x1, x2, plus our 1 over J and 0, and that is by the T. Next we have our output variables, y1 equals x1, y2 equals x2, and we can finally get to our final matrices of 1, 0, 0, 1. And here's our time domain / our curve. We started with our time domain function, brought this in from equation 3, and we just put it 1 over equation 3. Then we're going to find our inverse of the equation. This was the numbers that I came up with. Then I have in the bottom corner my curve with my input and my output, and then I plotted a couple points to get that curve shape. And that is it. Thank you. If you have any questions, please let me know.